Hello, my name is Akash, and this is my capstone project for the MAT 496 course on large language models offered in Shiv Nadar University by Professor Ajit Kumar. Without any further ado, let me start off with an introduction of the project itself. This project is a proof of concept for a direct Indic NLP translation tool. I set out to solve a long-standing problem in multilingual NLP, specifically in the context of Indian languages. India alone has more than 22 officially recognized languages, with vast linguistic diversity and variety in scripts and syntax. And yet, despite this diversity, almost all machine translation systems still rely on the usage of English as a pivot language. This means that if I were to convert one Indian language to another, I would first convert the source Indian language into English and then use the English translation to convert it to the target Indian language. This design choice is very limited, of course, and it exists only because parallel corpus between Indian languages are extremely limited. So there are datasets with English and Indian languages together, but there are no Indian to Indian language pairs that can facilitate a proper NLP translation. Now, this has a lot of measurable drawbacks. One is the loss of semantic nuance. Since a lot of Indian languages have similar grammatical structure, loanwords, cultural references, and they even stemmed from very similar languages. As a result, all of these lexical similarities and whatnot just cannot be represented by English properly. You always lose some context while you're translating, which I hope to minimize using this project. So I've built an Indic to Indic translation agent that does not use English as a pivot language during the retrieval of RAG context. This was done with Langgraph along with a variety of machine learning models like sklearn, which is scikit-learn, NumPy, pandas, which were pandas was for the data frame. I'll go into detail. Now the challenge is that high quality data sets for Indian to Indian translation just do not exist. So how can I get aligned Indian sentence pairs in the absence of this? I've used AI for Bharat's Samanantar dataset. I apologize for the horrible pronunciation. This dataset has millions of sentence pairs from English to 11 Indian languages. I'll just show it on screen. Yeah. So this, for example, is the Samanantar dataset for English to Punjabi. It has multiple different languages. It has 11 languages in total, and it has millions of language pairs for each. So the context is huge. Now, of course, yeah, okay. So I'll explain the idea while I show you the functions I wrote to generate my own Indic language pairs. So it starts with this function, build Indic-Indic fuzzy. It's a fuzzy aligned sort of translation method. What I've done basically is, okay, for example, if I want to translate from English to Odia, if I want to translate from Hindi to Odia, now in Samanantar, only English to Hindi and English to Odia pairs exist. So if an English sentence in the English to Hindi split is semantically very close to the English to Odia splits English sentence, then the respective Hindi and Odia translations become an aligned pair. So for example, in the Hindi dataset, let's say there's an English sentence that says the police have started investigation and a Hindi translation for the same. Suppose in the English to Odia dataset, there's an English sentence that says police have begun investigating the case. Now, the semantic similarity in English for these translations is very, very high. So we can use them to represent the same meaning to be treated as an aligned Indic-Indic language sentence pair. Um, do note that this is only during the alignment of pairs, and I do not use English as a pivot language during actual translation. So now, what this function does internally is it loads the Samananta splits from Hugging Face. I give them a sample size of say 4,000 sentences from each split to manage the load on my computer. We can scale this, and I will get to that later. It extracts the English sentences from the source in the target language. It Right. It uses sentence transformers multilingual MPNET model to create embeddings. I use NumPy to normalize those embeddings, and then I use scikit-learn inbuilt nearest neighbors learner to find the closest English sentence to the target dataset. So then I computed the similarity scores and kept only those above the threshold. Um, and then built a pandas data frame of aligned pairs as listed here. And finally, I used ChromaDB to embed and store only the source sentences with metadata containing the target indic sentences. So now I have large scale pairs of indic sentences without using English at all. Now this I'll use to train the LLM sort of using RAG and feed this as the context for it. I've also created a load or create vector store helper, which ensures that we do not have to rebuild the database dataset every single time if it already exists on my disk. So it'll see if suppose I have this Chroma database on my disk already, then it'll simply use that for whatever translation purpose I have. Now, if I don't have it, then it'll call the build indic fuzzy function to build a dataset for it. Now, If there isn't any Samanantar pair that's available for this, then when it goes to the context retrieval part, it'll automatically skip it because there's no retrieve context to be found because none of the languages that I want to translate exist in the data. Now, of course, I apologize for boring you with the technical jargon. I'll get to the part which is actually important for my grade, which is the Langgraph workflow. So my graph has the following nodes. It has identify intent, retrieve context, tool router, and direct translate. This is sort of the workflow of it. It goes from identify intent. Um, it starts and then it goes to the intent identification to the router tool, and then it has a conditional edge which determines whether to retrieve the context, as in for RAG, or if I should go to direct translation already. To be more precise, what this does is the identify intent. Um, in the identify intent node, I use a pedantic structured output model to extract stuff like the source language, target language, and of course the text to translate in itself. And tool router, as the name suggests, is just to sort of see if I should go to retrieve context first, or if I should go to direct translation if the Samanantar dataset does not have the required Indian language. Now, retrieve context uses ChromaDB to perform semantic search over the generated Indic-Indic pairs. It uses top K sampling to retrieve the most relevant example pairs, which act as RAG guidance for the LLM for translation. And of course, the direct translate tool, it just gives the LLM strict direct translation instructions, and it gives the RAG context, if any, for the final translation. After this, the graph terminates. Now, let me actually execute the program. So the Indian languages are a little off when it comes to representing it in PSC, which is why it's a little butchered here. But let's say I have, let's say, okay, let's do this. Um, I am Akash and I love to eat vanilla ice cream. Let's say I have this and I want to translate this to, let's say, Tamil. Now, as you would have noticed, I already have Hindi to Tamil as a dataset here. I had actually created all of these pairs beforehand, just for the purpose of demonstration, because creating these datasets takes a lot of time, which is a limitation of this. Uh, Before I show you that, this is my final translation. For my name is Akash, and I love to eat vanilla ice cream from Hindi to Tamil. Now, let's say I have copy pasted this into here. It says it's almost the same. Instead of I am Akash, it says I am Akash. Close enough. Um, so you can also create more data sets if you'd like. I've created all of these language pairs using a simple for loop of calling the building function again and again. The problem is that this takes 4 to 7 minutes even for each data set, and the limitation is that my sample size is only 4,500, which I've mentioned here specifically. For actual use cases, it needs to be up to around 30,000 to 50,000. Now, let me run this on Streamlit, and I shall show you that as well. Have this sort of basic UI that I use Streamlit for, very easy to make. So this sort of has a polished UI. It does the same thing. This time around, since I've already demonstrated how it works when I already have retrieve context, now I'm going to try a data set which I haven't had before, which I haven't installed before. I've created these data sets, all of these, which correspond to these translations. Let's say I want to do um, Punjabi to Bengali. Let's suppose I don't have it installed. I haven't created it using my own script, so it will do that automatically for as part of the graph. Um, and yeah, let's say I have uh, the sky is blue in color. Translate this to Bengali. Now this time around, it'll take a longer time because it has to create the data set itself using the function for it. See the see it happening in the terminal here. It loads the Samanantar splits for Punjabi and Bengali, and then it does the actual creation. Right. So it checks the so a lot of this all of this happens from the identify intent node to the retrieve context node. Of course, after it identifies what I'm saying, what input I've given it, it will go to the retrieve context node, and that will call the load or create vector store function, which in itself calls the build indic fuzzy function, and that it does it to check if it's there in the vector store already. If not, it will create it in the vector store. Now, of course, we have gotten 76 indic aligned pairs at uh, Punjabi to Bengali here, and I will commit that after this video, and you can check it out for yourself. And you can see the results here, detected source language. And here are the retrieved examples. So it has a source and target. These are the most contextually relevant examples that it found. And this is the final translation. Now let's say I have the sky is blue. It's not the sky is blue in color, it's the sky is blue, which is close enough, which is what we expect for a sample size of 4,500. Now, for the scope of the project, it ties down to the limitations of it. Embedding such large splits is very time consuming on the CPU. So my sample size of 4,500 is in fact not enough for actual generalized use. We will need a sample size of at least 30,000 or 50,000 per language, which could take hours to create. Another limitation is that since these are fuzzy matches, the alignment of the pairs are not perfect in any sense, and we can get very wrong translation. This can be resolved by setting the threshold for semantic similarity to something like 0.9 or 0.95 to enable accuracy. But since my sample size is lower, I am working with a threshold of 0.7. And this can also be tackled by using GPU acceleration or even fine-tuning a multilingual model on my Indic-Indic data. I need to figure out how I would be able to use GPU acceleration to build a larger parallel corpus with a sample size of up to, say, 1 lakh sentence pairs per language. And I also plan to convert the Streamlit app into a public demo once I figure this out. In conclusion, I have built a fully Langgraph-powered Indic-Indic translation tool using NLP, RAG, semantic search, and structured output, among others, along with a relatively polished UI with my own list of datasets that I have already done generated using RAG. Thank you so much.